This video is going to look at the law of cosines. Just like we looked at the law of sines in previous videos, here we're going to use the law of cosines in this video if we're given the three sides of a triangle. That will allow us to solve for the three angles of the triangle. And the formula states that if we can take the cosine of angle A, that's going to be equal to b squared plus c squared minus a squared, and that's all divided by 2 times b times c. And of course, we're thinking of our triangle. If we have angle A, angle B, and angle C, and then of course we have side little a, side little b, and side little c. So here you notice that if we have all three sides, in this case side A, B, and C, then we can use that to solve for angle A. And of course, we could use the same formula to solve for angle B. We would have the cosine of B, except for that would simply then be a squared plus c squared minus b squared all over 2ac. And then if we wanted to look for angle C, we could always take the cosine of angle C, and that would be equal to a squared plus b squared minus c squared. And that's divided by 2 times AB. So hopefully you can kind of see a pattern here. Depends on what you're looking for. If we're looking for angle A, then that means we're going to take the two sides that make up angle A. In other words, we're going to take side B and C, b squared plus c squared, and the side that we're going to subtract away is going to be side A. So you're going to notice that the angle A is going to match up with the part that we're going to subtract away for side A. Just like down here, if we're looking for angle B, we're subtracting away side B. And same thing for angle C, you're subtracting away side C. So really the formula is, once you look at it, fairly easy to memorize. So here, if we have an example, if we're given a triangle where we know all three sides, okay, so we're given side, side, side. If we have A equals 9, B is equal to 3, and C is equal to 11. Okay, so then we would have to sketch our triangle, and we'll know that we have A, B, C. Now once again, this isn't drawn to scale. I'm just drawing a picture so we can see a triangle and visualize the sides and the angles that we have. So here we have little a is equal to 9, and side B is equal to 3, and C is equal to 11. So here we want to solve for angle A, angle B, or angle C. Now we can actually use the law of cosines and we can solve for any angle, but there is one technique we can use here. If we find the largest angle, if we find the largest angle first, okay, if we find this largest angle first, then what that means is if that angle turns out to be obtuse, then we can use the law of sines to finish solving the triangle. So this is something we can use to make things maybe a little bit easier, and as we go through this example I'll point out what I mean here. So first of all, if we want to find the largest angle first, well, how do we know which one's going to be the largest angle? Well, we simply look at the largest side, which is 11, so that means if side C is the largest, that means angle C has to be the largest angle. So if we go to find side C, or angle C rather, that would be the cosine of C is equal to, okay, then we would have a squared plus b squared, so that's 9 squared plus 3 squared minus side C squared, which is 11 squared. And this is all divided by 2 times AB. Well, that's going to be the same numbers right above here. So it's 2 times 9 times 3. And here we could simply go to the calculator. And you want to be careful when you enter this into the calculator because you want to make sure that the entire numerator, if you want to put this all at one time into the calculator, the entire numerator must be in parentheses. Or we can do it this way. We could simply type 9 squared plus 3 squared minus 11 squared, and we could hit enter so that we make sure we get the calculation, and then we have a negative 31 divided by parentheses 2 times 9 times 3, close the parentheses, and again we have to put parentheses here because we want to multiply the 2, the 9, and the 3 before we divide it into the negative 31. And we get a negative 0.574. So now this tells us that the cosine of C is equal to a negative 0.574, okay? But now that's not angle C, that's what the cosine is. So this is where we're going to have to use the inverse function, okay? So we need to find the inverse cosine. So if we go to the calculator, now instead of rounding this decimal, I'm going to actually go second cosine. So there's the inverse cosine, and I want to bring down the entire decimal, the negative 0.574074 and so on. And I'm just going to hit the second function key and the negative key here at the bottom of the calculator where it says answer, and it will bring down the very last answer without rounding that decimal. So you'll end up with a more accurate answer. So now when we hit enter, we get 125. And I forgot to remind you here, we're dealing with the angle in degrees, so make sure if you didn't get 125 here, make sure you go into mode and make sure that you have degree mode selected. So this is 125 degrees, so that tells us angle C is 125. Now, based on the idea that over here, this was the first angle we found, which was the largest angle, and it is obtuse, then what that means is if it is obtuse, then we can then use the law of sines to finish solving the triangle. Now, the reason we can now use the law of sines is because we have an angle in the side opposite of that angle. So, for example, here, if we wanted to then find angle A, then we could say the sine of A over 9 is equal to the sine of 125 degrees over 11. So that means here we would end up with the sine of A is equal to, and here we would need to multiply by 9, so we would have the sine of 125 over 11 multiplied by 9. And if we go to the calculator here, we would take the sine 125 degrees, close parentheses. We want to divide that by 11. Okay, then we're going to multiply by 9. And notice because I didn't put parentheses here, it's actually going to divide the 11, the sine of 125 by 11, then we're going to multiply by 9, and we end up with 0.670. So that would be 0.670. So if we want to find angle A, we need to find the inverse. So I'm going to do like I did before. I'm going to go second sine, and I'm going to go second negative key here at the bottom, so that brings down the entire decimal, brings down the last answer. And when we hit enter, we get an angle of 42 degrees. So that tells us that angle A is 42 degrees, and we know that this is 125 degrees. So that means we can easily then find angle B by simply taking 180 degrees minus the 125 minus 42, And if we do that, you would have 180 minus 125 minus 42, whoops, 125 minus 42, we end up with an angle of 13 degrees. So here we have now found the three missing angles. Now I want to show you that here we used up here the law of sines. Now if this angle that we found up here first, the largest angle, if this 125 was not obtuse, we would have to use the law of cosines again. And if you don't want to have to think about whether you can use the law of sines or not, you certainly could have used the law of cosines to find angle A. And let me go through and show you that. If we want to use this in using the law of cosines, we would have certainly just said the cosine of A, okay, and then we would have to take our, if we're looking for A, then we're going to use B and C, so it'd be B times C, or B squared plus C squared rather. So that means we would end up with 3 squared plus 11 squared minus the side here opposite, which is A, so that's 9 squared. Okay, so again, that's just simply going back up here and using this formula because we're looking for A, so it's B squared plus C squared minus A squared, all divided by 2BC. So for us, that means we're going to divide all of this by 2 times BC. Well, B and C would be the 3 and the 11, so that's times 3 times 11. And if we enter all this into the calculator, let's clear all this out, we would take 3 squared plus 11 squared minus 9 squared. And I realize I forgot the parentheses here, so I'm just going to simply hit enter. So we get the top is 49 and then divided by parentheses 2 times 3 times 11. And we get approximately 0.742. And once again, so that we don't round and we want to actually find the angle, I'm going to simply hit second cosine. We want to find the inverse cosine, and then I'm going to hit second function answer, and we end up with the same angle of 42 degrees. So if you don't want to have to worry about whether you can use the law of sines or not, then we can certainly always just simply use the law of cosines. And I'm not going to go into the detail here, but the one reason that we can't really use the law of sines if the first angle we find here isn't an obtuse angle, because if you remember when we used the law of sines, we ended up with situations where we could have two solutions. Well, here, because we have the three given sides, we really can only have one solution, but using the law of sines, we may end up finding the wrong angle. So that's why we need to have an obtuse angle if we're going to continue through the process using the law of sines. So again, if this wasn't 125 degrees, if it was less than 90, then we would have had to have gone down here and used the law of cosines. Okay, so this video shows you how we can use the law of cosines if we have three sides of our triangle. Okay, and there we have the three different forms whether you're looking for angle A, angle B, or angle C. And the next video we're going to look at how we can actually use the law of cosines again if we're given side, angle, side. So where we're given two sides and the included angle.